Hello everyone, this is Mr. Molo for lesson 7-7, factoring special products. So kind of like lesson 7.3, this is kind of a repeat of lesson 7.6 where we're just factoring. And then the fact that it says special products, that means everything in this lesson is going to be perfect squares. So as long as you know your perfect squares like you did for lesson 7.3, it's going to be pretty similar then. So like if we look at letter A here, we have 4 and we have 1. Well, we know the square root of 4 is 2. So you're going to have a 2x and a 2x. And then we have the minus 1. Square root of 1 is 1. But since it's a minus 1, we know we need a positive 1. And we need a negative 1 there. So going to be pretty similar to that. Let's look at some examples. So s squared minus 49. Again, if you look at all these, 49, 81, 16, 4 and 25, 36, 121, 81, and 49. They're all perfect squares. So 7 times 7 is 49. So really you just kind of got to figure out what the signs are going to be. Is it going to be s plus 7 and s plus 7, or s minus 7 and s minus 7, or one of each? So since I have a negative 49, we can figure out it's going to be s plus 7 and s minus 7. And some of you might be asking, well, what happens to that middle term? So if I do that, we have s squared. We have a negative 7s, we have a positive 7s, and we have that negative 49. So we have a negative 7s and a positive 7s, which cancel out to be 0. So we're just left with s squared minus 49. And that's pretty much how all these are going to be. Square root of 81 is 9, so I'm going to have a t plus 9 and a t minus 9. And then same thing, the positive 9t and the negative 9t are cancel, and we're left with that. 3 kind of tries to trick you here with this x squared, but pretty much kind of the same thing. So you can write it backwards. So 4 plus x and 4 minus x. And again, your positive 4x, your negative 4x are all going to cancel. 4, 5, and 6 have 2 numbers there, but again, they're both perfect squares there. 4 and 25 are both perfect squares. The square root of 4 is 2, and the square root of 25 is 5. And same thing on the other side. Positive 2 and a negative 5, so that you get that negative 25. Then same thing, if we test it out, double check, we get, 2 times 2 is 4g squared. 2 times negative 5g is negative 10g. 5 times 2g is positive 10g. And then 5 times negative 5 is negative 25. Positive 10g, negative 10g cancel, 0. So we're just left with that 4g squared minus 25. Just like it says in the problem. Same thing on number 5. We have 36h squared. So the square root of 36 is 8, or square root of 36 is 6. Square root of 121 is 11. So 6h minus 11 and a 6h plus 11. Same thing for the last one here. We have 81. Square root of 81 is 9. And then we have 49. Square root of 49 is 7. So a little bit easier, I think, than yesterday's lesson because we know all these perfect squares. And then kind of the same thing, they kind of throw in these random multiplication problems. You can just do these on the calculator, or you can do it in the same way we did it in lesson 7.3, where you're squaring them and figuring it out. Otherwise, you can kind of just use the calculator. So here, this one's like 440. This one's 420. So kind of using the same way with those parentheses of 57 squared is the same as, 50 plus 7 and things like that. So these, same thing, it has 3 numbers this time, and that's only because then these signs are going to allow us to have some numbers. So we're going to have 2 of the same signs. So since everything is positive in number 13, I know it's going to be x plus and x plus, and then the square root of 64 is 8. And if we test that out, that gives me x squared, that gives me 8x, that gives me 8x, and that gives me 64. And if I combine 8x and 8x, I get 16x. So as long as you know your square roots, you should be good. Same thing here. We have p plus square root of 196 is 14. And p plus 14 as well. And then another way the book might write it is, since you have the same thing twice here, they might just want you to write p plus 14 squared. And then same thing here, x plus 8 squared. 15, now that I have a negative 26 and a positive 169, that means I need a negative 13. Square root of 169 is 13. So our minus 13 and our minus 13, because negative 13 times negative 13 is still a positive 169, and negative 13 plus negative 13 is negative 26. So r minus 13 squared. Then still continues down here for 17 and 18, even though we have numbers here in front of the c, but since we're talking about special products, we know it's always going to be square roots. So square root of 36 is 6, square root of 49 is 7, and then same thing, 6c plus 7. And then let's test it out. So that's 36c squared, that's 42c, that's 42c, and that's 49. So a little easier. We don't have to think about, oh, how are they getting 49? Are they doing 49 and 1 or 7 and 7? Since this is special products, it's always going to be that perfect square root there. Same thing with 36. You don't got to wonder if it's, 6 and 6 or 9 and 4, 18 and 2. You can just always do the perfect square root. Okay, so it checks out, and then kind of the same thing. You could write it as well as 6c plus 7 squared, since it's two of those in the same box. All right, let's do one more. So square root of 100 is 10. Square root of 1 is 1. And then square root of, oops, so it's supposed to be a minus. And then square root of 10, 100 is still 10, minus 1. And then if you add negative 10 and negative 10 together, you would get that negative 20. Okay, 19 through 24, kind of the same thing, except now they want us to solve. So after we get our answer, we need to set them equal to 0 and figure out what it is. So x squared minus 144. So the square root of 144 is 12. So x plus 12, x minus 12, just like we did on the first 18 problems in this section, and then set them equal to 0 to solve. So x plus 12 equals 0. So subtract 12 from each side. So negative 12 is one answer. And then same thing, x minus 12 equals 0. Add 12 to each side. So x equals positive 12 is my other answer. Okay. 20, it's not written where it equals 0, so we have to do that first. So subtract 49 from each side. So we get 9y squared minus 49 equals 0. Same thing, both of these are perfect squares. So square root of 9 is 3. Square root of 49 is 7. So 3y minus 7 and 3y plus 7. Same thing, set both of them equal to 0. So 3y minus 7 equals 0. And 3y plus 7 equals 0. And your only difference in these two steps is here you're adding 7 first, then dividing by 3, so you get 7/3 as one answer. And over here, since it already is a plus 7, you need a minus 7 first. So divide both sides by 3, and now you have negative 7/3 as your answer there. Okay, and then remember, you still will get some weird ones like number 22. So square root of d is just d, square root of 4 is 2. And you get d minus 2 and d minus 2. So since they're both the same, d minus 2 equals 0. Add 2 to each side, add 2 to each side. Here you only get one answer for these. And it's going to be d is 2. 23 and 24, same thing. They might look harder because they're fractions, but really it's going to be the same thing. Let's look at 24 to kind of show you. So first, it's not set up where it equals 0. So I'm going to add k squared to each side. So I'm left with k squared minus 6/5 k plus 9/25. And then if you don't remember how to find the square root of a fraction like that, remember you're just taking the square root of both numbers. So the square root of 9 is 3, and the square root of 25 is 5. So k minus 3/5 and k minus 3/5. You multiply 3/5 and 3/5, you get 9/25. You add negative 3/5 and negative 3/5, you get negative 6/5. And then same thing, k minus 3/5 equals 0. So add 3/5 to both sides. And we're lucky since they're both the same. This is going to be another one where there's just one answer. K equals 3/5. So remember, you're plugging in these to try and figure out which numbers will make the equation actually equal 0.